Glimpses of Modern Science, Class 7. Chapter 4. Heat. Heat is energy. Heat is a form of energy which causes the sensation of hotness and coldness. When water is stirred in a river, it gets warm. Here, mechanical energy of the stirrer gets converted into heat. When you rub your hands against each other, they get warm. Here, kinetic energy of the hands gets converted into heat energy. So, these examples show that heat is produced wherever some other form of energy is used up. Unit of heat. The unit of heat is calorie. 1 calorie is that amount of heat which can raise the temperature of 1 gram of water by 1 degree Celsius. Calorie is abbreviated as cal. We also use the kilocalorie to measure the amount of heat. 1 kilocalorie equals 1000 calories. Kilocalorie is abbreviated as kcal. Hot and cold. Objects around us can be hot or cold, but hot and cold are relative terms. The reliable measure of hotness or coldness is temperature, which indicates the degree of hotness. Higher temperature means a hotter substance. Temperature can be compared in 2 ways. By sense of touch, which helps us feel differences, e.g., hot milk versus lukewarm water, but does not tell the exact extent of heat, and by using a thermometer, a reliable device that accurately measures temperature. Measuring temperature. A thermometer is an instrument which is used to measure temperature. It works on the principle that when the heat reaches the liquid, it expands and its level rises. On cooling, the level will go down again. There are different types of thermometers. Alcohol and mercury are generally used in making a thermometer. Mercury is preferred to other liquids because of its properties. A clinical thermometer is used for measuring body temperature. B. Laboratory thermometer is used for laboratory purposes. Laboratory thermometer. A laboratory thermometer consists of a thin glass tube sealed at one end and a bulb filled with a liquid at the other end. It is called mercury thermometer because mercury is the liquid used in it. A laboratory thermometer cannot be used to measure body temperature because the temperature recorded in it will fall when it is taken out of the mouth. Temperature scale. The temperature is measured on the Celsius or Fahrenheit scale. However, the Kelvin temperature is used for scientific work. The temperature on Celsius scale is measured in degrees C. It is read as degrees Celsius. Its lower point is 0 degrees Celsius and upper fixed point is 100 degrees Celsius. The temperature on Fahrenheit scale is measured in degree F. It is read as degree Fahrenheit. Its lower fixed point is taken as 32 degrees Fahrenheit and the upper fixed point as 212 degrees Fahrenheit. Transfer of heat, heat flow. 1. Conduction. Conduction is the transfer of heat between 2 objects in contact or within one body, moving from the hotter part to the colder one. It stops when both reach the same temperature. Good conductors like copper, silver, and iron allow heat transfer easily, while insulators like wood, air, and plastic resist it. For example, a thermometer works by conduction when mercury absorbs heat from the hot object. 2. Convection. Convection occurs in liquids and gases, where hot fluid rises and cold fluid sinks, creating currents that transfer heat energy. For instance, sugar dissolves faster in hot milk due to circulating convection currents. Sea and land breezes are also results of convection. During the day, cooler sea air moves to land, sea breeze, and at night, cooler land air moves to sea, land breeze. Applications include ventilation of houses, warm air rises and escapes through ventilators, central heating systems, hot water or oil circulates through pipes, and thermos flasks, reducing heat loss through convection. 3. Radiation. Radiation transfers heat directly without any material medium, even in vacuum, like sunlight reaching Earth. The absorbed heat depends on distance and color. Black surfaces absorb more heat, while shiny or light surfaces reflect it. Applications include black bottom utensils for cooking, solar cookers, silvered surfaces in thermos flasks, wearing light clothes in summer, and solar cells absorbing sun's energy. Kinds of clothes we wear in summer and winter. During summer, we prefer to wear light-colored clothes because they do not absorb heat and are pleasant and soothing to eyes. During winters, we prefer to wear dark-colored clothes because they absorb heat. If we wear dark shaded clothes during summer and light shaded clothes in winter, then what would happen? Dark surfaces absorb more heat. Therefore, we feel more comfortable with dark-colored clothes during winter. Light-colored clothes reflect most of the heat that falls on them. Hence, we feel more comfortable in light-colored clothes during summer.